In this video, we are going to see about what a p-value tells you about statistical significance. What is p-value? A p-value, or probability value, is a number describing how likely it is that your data would have occurred by random chance. That means that the null hypothesis is true. The p-value is a number calculated from a statistical test that describes how likely you are to have found a particular set of observations if the null hypothesis were true. P-values are used in hypothesis testing to help decide whether to reject the null hypothesis. The smaller the p-value, the more likely you are to reject the null hypothesis. When you perform a statistical test, a p-value helps you determine the significance of your results in relation to the null hypothesis. The null hypothesis. The null hypothesis states that there is no relationship between the two variables being studied. One variable does not affect the other. It states the results are due to chance and are not significant in terms of supporting the idea being investigated. Thus, the null hypothesis assumes that whatever you are trying to prove did not happen. The alternative hypothesis. The alternative hypothesis is the one you would believe if the null hypothesis is concluded to be untrue. The alternative hypothesis states that the independent variable did affect the dependent variable, and the results are significant in terms of supporting the theory being investigated, i.e., not due to chance. How do you know if a p-value is statistically significant? A p-value, or probability value, is a number describing how likely it is that your data would have occurred by random chance. That means that the null hypothesis is true. The level of statistical significance is often expressed as a p-value between 0 and 1. The smaller the p-value, the stronger the evidence that you should reject the null hypothesis. Case 1. A p-value less than 0.05 typically is less than or equal to 0.05. A p-value less than 0.05 typically is less than or equal to 0.05, is statistically significant. It indicates strong evidence against the null hypothesis, as there is less than a 5% probability the null is correct, and the results are random. Therefore, we reject the null hypothesis, and accept the alternative hypothesis. However, if the p-value is below your threshold of significance, typically p less than 0.05, you can reject the null hypothesis, but this does not mean that there is a 95% probability that the alternative hypothesis is true. The p-value is conditional upon the null hypothesis being true, but is unrelated to the truth or falsity of the alternative hypothesis. Case 2. A p-value higher than 0.05, typically greater than 0.05. A p-value higher than 0.05, greater than 0.05, is not statistically significant, and indicates strong evidence for the null hypothesis. This means we retain the null hypothesis, and reject the alternative hypothesis. You should note that you cannot accept the null hypothesis, we can only reject the null or fail to reject it. A statistically significant result cannot prove that a research hypothesis is correct, as this implies 100% certainty. Instead, we may state our results, provide support for, or give evidence for, our research hypothesis, as there is still a slight probability that the results occurred by chance, and the null hypothesis was correct, e.g. less than 5%. Example of p-value. You want to know whether there is a difference in longevity between two groups of mice fed on different diets, Diet A and Diet B. You can statistically test the difference between these two diets using a two-tailed t-test. Null hypothesis. There is no difference in longevity between the two groups. Alternative hypothesis. There is a difference in longevity between the two groups. If the mice live equally long on either diet, then the test statistic from your t-test will closely match the test statistic from the null hypothesis, that there is no difference between groups, and the resulting p-value will be close to 1. It likely won't reach exactly 1, because in real life, the groups will probably not be perfectly equal. If, however, there is an average difference in longevity between the two groups, then your test statistic will move further away from the values predicted by the null hypothesis, and the p-value will get smaller. The p-value will never reach zero, because there's always a possibility, even if extremely unlikely, that the patterns in your data occurred by chance. If you are comparing only two different diets, then a two-sample t-test is a good way to compare the groups. To compare three different diets, use an ANOVA instead. Doing multiple pairwise comparisons will result in artificially low p-values, and lets you overestimate the significance of the difference between groups. No matter what test you use, the p-value always describes the same thing. How often you can expect to see a test statistic as extreme or more extreme than the one calculated from your test. Your comparison of the two mouse diets results in a p-value of less than 0.01, below your alpha value of 0.05. Therefore you determine that there is a statistically significant difference between the two diets. In our comparison of mouse diet A and mouse diet B, we found that the lifespan on diet A, mean equals 2.1 years, SD equals 0.12, was significantly shorter than the lifespan on diet B, mean equals 2.6 years, SD equals 0.1, with an average difference of 6 months, T, 80, equals minus 12.75, P less than 0.01.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.